This is Circuits 1. I'm Dr. Hartman, the program chair for electrical engineering. My office is across the street, I guess catty corner, over in Nefkin 211. My office hours are Tuesday and Thursday from 10 to noon, and then from 1:30 to 4:30. In addition to these office hours, I and the Electrical Engineering Honor Society offer free circuits tutoring on Mondays and Wednesdays from 4:30 p.m. until 5:30 p.m. over across the street in Nefkin Hall as well. I'll put something up on Moodle and probably put something on the board as soon as we finalize a room for that. That's going to start next week because there's really no reason to have it this week per se. Okay. So that means that I am available roughly 12 hours a week outside of class to help you guys with circuits. Okay, so I'm trying to be, I don't know, approachable and available and all that kind of jazz. So if you have any questions, by all means, come by and ask. My email is my last name at latech.edu, and my office phone number is listed here. That's a terrible way to contact me because I teach so many classes. Email me or come by my office hours is a much better way to try to catch me. All right, so emergency class disruption policy. If we have to go back to fully online or anything like that, the class is going to continue over Moodle and Zoom. Some of you may have noticed that I have Zoom up and all that kind of stuff right now. I actually record all of my lectures and all that kind of good stuff. So I'm giving you guys the option. If you don't want to physically be here, you can attend class virtually over Zoom. Or if, I don't know, waking up at 8 o'clock in the morning is a terrible, terrible thing for you all, which it is for some of you, you could effectively take the class asynchronously-ish because I'll be recording all of the lectures and all that kind of good stuff and then posting them on my YouTube channel and on Moodle so that the only time you'll actually physically need to be present is exams, if that's the way that you particularly care to do things. I try to be as accommodating as possible. So let's see, course objectives. At the end of the quarter, you should be able to apply circuit analysis techniques to a variety of circuits. That's kind of the whole purpose of this class. The textbook officially is Engineering Circuit Analysis 9th edition by Height, Kimmerly, and Durbin. Unofficially, there's no need for you to buy a textbook for this class because we're not going to use it for literally anything. All of the lectures are going to be recorded. All of the homeworks and all that kind of good stuff are on WebWork. Having a circuit analysis textbook isn't necessarily a bad idea, but I don't want to make you guys go spend, God only knows, probably close to $200 on a textbook you're not going to use. So for those of you that are playing around on your laptop right now, if you open up your browser and search for ULABY, the first link is a textbook called Circuit Analysis and Design by Fawad Ulabi and some others. Fawad Ulabi is the director of the college or of the electrical engineering, I guess the School of Electrical Engineering up at the University of Michigan. And he and some friends have written the textbook and they have put the PDF copy online totally for free. So you don't have to arguably feel bad about stealing textbooks for free off the internet and all this kind of stuff. This guy's literally just putting it up there for anybody and anybody who wants to use it. So if you feel the need to find a textbook, this is the one that I would recommend because you're not taking money out of anybody's pockets by finding it on the internet. All right. Disability disclosure stuff. Students that need testing or classroom accommodations based on a disability need to discuss those needs with me as soon as possible, and also talk with TDS. Okay. If you have ADHD or any other type of learning disability that qualifies you to get extended time on your exams and to take them in a quiet room, I highly, highly encourage that you go ahead and put the wheels in motion to get those benefits. It cannot hurt you to take the room without 60 people next to you shuffling papers and all that kind of crap, making noise, etc. I've had several students in my multiple years of teaching this class who decided to take the first exam, students who had a legitimate disability recognized by TDS, decided to take the first exam in the common room with everybody else. And then after that said, oh, that's not for me, I'm gonna go take it in the quiet room. Don't waste a test grade figuring out that you should be taking the exam in the quiet room and all that kind of stuff with minimal distractions, okay? If that is a legitimate option for you, exercise your right and get that done. Save yourself a terrible exam 1 grade. Let's see. Class attendance. I am required to take roll every day and all of that kind of stuff. That being said, I do not have any particular preference as to whether you attend this class physically or virtually, either synchronously or asynchronously, or if you choose not to attend it at all. You're adults, you're paying money to be here. If you want to squander that money, that's your prerogative. There is a direct correlation between your showing up and paying attention and your ability to do well on my exams, but that isn't for everyone. I've definitely had students who never showed up and still managed to pull A's in this class. So if that's the gamble that you want to take, by all means, take it. Academic misconduct, effectively, don't cheat and be less rude than I am, and we'll be great. All right, homework. Selection of homework problems will be posted on WebWork at the end of each lecture. You'll be granted unlimited attempts. Technically, some of them are set for like 100-something attempts because something got messed up, and once you set it to have some numerical value, you can't unset it to be infinite. So anyway, if for some strange reason on those few problems it literally takes you more than the 100-something attempts that you're given, let me know and I can give you more attempts. But if it's taking you 100 attempts to work something, you should come ask me what you're doing wrong first anyway. All right. The specific due date for each homework assignment is listed in WebWork. How it's typically set up is that there's a specific due date for the homework, and then I think you can get half credit if you finish it within the next day or two, and then after that, you're kind of out of luck. So if you don't keep up with your homework in this class, it can hurt you quite a bit, but there is a little bit of a grace period. The next topic here is in-class assignments. So after every lecture except today's, a brief problem set will be distributed. I used to hand them out. Now I just post them online. If we look at the courses Moodle page, I have it set up for all of the different class meetings, and the in-class assignment will be in this thing. I don't have them set up just yet, but you should expect to see the in-class assignment show up here prior to class. An online submission portal. I want all of your work that you give me submitted electronically. That way there's no chance for me to lose it, because my office is an absolute shit show most of the time. And then they're going to be due, as it were, prior to the beginning of next class. So like at the end of Friday's lecture, your in-class assignment will be due before Monday's lecture. The solutions will also show up right before Monday's lecture. So I provide you my solutions to the in-class assignments. And the reason that I do that is because I didn't make the WebWork. We've been using the same old terrible WebWork problems for the better part of, I think, 8 years at this point. And I don't necessarily think that they are bad problems, but I don't think that they're as representative of what I like to put on a test as what the in-class assignments are, because I make the in-class assignments and I make the exams. So as far as study materials go, the in-class assignments I believe to be a pretty effective thing to study from because they're made by the same jackass who is making your tests. Okay? I provide you with the solutions to help you kind of think your way through, or I guess help you figure out how I think my way through analyzing these problems. All right, let's see. Mini labs, there's going to be 8 mini lab sessions, or there's supposed to be 8, but sometimes I drop some because we get behind and all that kind of good stuff. Provided throughout the quarter. These labs are to be completed in groups of 2 to 3 students. Honestly, 4 is fine, but there's no reason for 6 of you guys to be working together on what I consider to be such simplistic lab assignments. Completion of these labs will practically always require the use of a digital multimeter and sometimes require the use of a Windows laptop. There are kits that are available that'll have all of the components that you'll use available in the project-based learning office down the hall. Honestly, not everybody needs to buy this little $10 kit. If you figure out a group of 4 and you each chip in $2.50, you'll be able to purchase the kit for your group and be good to go. Just make sure that, you know, somebody is going to actually show up on the lab days that has the kit to do stuff. All right. Exams. There are 3 exams given during this course. All of the exams are closed book and closed notes. If you have to miss an exam for any reason, you really need to let me know sooner rather than later. Only FE approved calculators are permitted for use during the exams. So while that's true, I'm going to make a suggestion, okay? I have a plethora of calculators. My preference for some parts of this class is this TI-36X Pro. This calculator does a fantastic job of doing complex number manipulation, which when we get to the third part of the class is going to be a whole lot of playing around with complex numbers, okay? This is my preferred calculator for that. And the reason is because it's got 8 variables that you can store things to very easily. So there's less chance of bookkeeping and calculation errors if you're just using stored values for everything. All right. Now in the first roughly 2/3 of the class, my preferred calculator is this guy. It's a Casio FX 991. I think this guy is like $16 and this guy is like $20. The reason that I prefer this calculator is it's the most powerful calculator that is on that FE approved calculators list. The TI-36X, the Casio 115 are only capable of solving systems of equations that have 3 equations, 3 unknowns. This guy can do 4 equations, 4 unknowns, which means you may have, you can get away with reducing or simplifying a circuit less and still come out with the correct answer using this guy. So this is my suggestion for all of the, effectively the DC portion of the class, because you don't have to do as much work. I'm not going to give on any exam a circuit that would require you to be able to solve a 4 equation, 4 unknown system. There will always be simplifications that could be made to reduce it to a 3 equation, 3 unknown system, or potentially smaller, so that you could use one of these other calculators. I'm just simply saying this guy means you need to do less work beforehand and can actually get to solving your system, which we're going to do an awful lot of. So I highly encourage you guys, if you're going to purchase any one calculator for this class, make it this one. And I can tell you very explicitly, if you're using like an old TI-30 or something like that, spend the $12 to $15 and upgrade to a better calculator. It's going to make your life much, much, much easier. Okay. All right. So here is the grade distribution for this class. Homeworks are 15%, so that's a letter grade and a half. If you do not keep up with your homeworks, you are shooting yourself in the foot in this class. The in-class assignments are 5%. I don't think I mentioned this a moment ago when I was talking about the availability of the in-class assignments and all that kind of stuff. In-class assignments are not graded for correctness or completeness, okay? They are a measure of your participation. So the expectation is that I'm not going to talk for the full 2 hours or whatever that this class is supposed to be, because nobody wants to hear me talk that long about circuits. Typically speaking, I wrap up my lectures somewhere between 45 minutes and an hour and 15 minutes. There's maybe one or two that go a little longer. There's maybe one or two that are actually shorter than that. The remaining class time, I'm expecting you guys to spend on the in-class assignments, where I'll just walk around the room, and if something doesn't make sense, you can say, hey, Dr. Hartman, help me make sense of this, or whatever, okay? So I'm gonna repeat this because it seems to be a point of confusion. I do not grade them for correctness, and I do not grade them for completeness. I want these to be an opportunity for you to take a crack at a problem in a low risk environment, to where it really doesn't matter whether or not you get it right or wrong. You're just trying to work it so that you can see where you're deficient and where things don't make sense. And then you can ask a question of either me or the people that you're working them with to be like, all right, let's figure this out, okay? So if you turn it in, you get 100. It is literally a participation grade. You just have to give enough of a crap to submit these things electronically prior to the beginning of the next lecture to get full credit for all of them, okay? The mini labs are a similar animal. If you're working on the labs, you're doing what you're supposed to do during these lab assignments. I really don't care what the results are. You're trying to learn to use the equipment, all that kind of good stuff. So effectively, a full letter grade in this class is dedicated to you proving to me that you can fake giving a shit enough to fool me, okay? I know that circuits and all that kind of stuff are not for everybody. I fully understand that. If you show me that you're trying, you'll get those full 10 points. If you sit at one of these tables and watch soccer on your phone, you'll get none of them. And I say that because that's definitely happened before. Okay. All right. Exam 1, Exam 2, and Exam 3 are both worth 30%, but there's that little symbol on the side there. So for those of you who are astute, you probably added all those numbers up and said, well, that equals 115%. Because I am a benevolent and magnanimous person, the exam that you score the lowest on, I will only count for 15% of your final grade, which means as long as you don't make less than a 33 on one of your exams, an A is still mathematically possible in this class. So effectively, you can have one pretty bad test day and still pass this class. I don't want to say easily, because it is absolutely going to require work, but you haven't completely shot yourself in the foot so hard that success is impossible, okay? I'm going to turn off my email. All right, so 15% for homeworks, 5% for in-class assignments, 5% for mini labs. The two tests that you score highest on are 30% apiece. The test that you score the lowest on is 15% for a total of 100%, okay? Because I offer tutoring sessions, give you exam review materials, give you the solutions to my in-class assignments, and reduce the weight of your lowest test score to 30%, I don't care. If you want to make an A in this class, you need to have literally a 90.000 or higher to pull an A. I feel like I'm generous enough in other areas that I can be a bit of a jerk here, okay? So if you want an A, you need to put the work in and earn it. I don't think anything in the syllabus will change, but if it needs to, for whatever reason, I reserve the right to do so as long as I tell you about it. Emergency notification system stuff. You should sign up just so you know when classes are canceled or move online or all that kind of good stuff. Let's see, COVID-19 policy stuff is all online. The short version is you're no longer required to wear masks in classrooms, which is why I'm not yelling at the overwhelming majority of you. If you're feeling sick, don't show up. I don't need an excuse, but if you get me ill, I'm going to be furious. So just to be very, very clear. I don't particularly care if it's COVID, the flu, or whatever, just don't get me sick or I'm going to be real, real mad. Okay. If you do have to go take a COVID test or anything like that, you need to report stuff to Stacy Gilbert, the Dean of Student Services and Academic Support, whose email address is listed here, stacyc@latech.edu. If you even email me something with the word COVID in it, I'm going to forward your email to this lady effectively to make sure that proper reporting protocols are being handled. All right. Any questions regarding syllabus stuff? All right. So let's get started on lecture stuff then. Let me close that. All right, so today is one of the very few days, quite possibly the only day that we're not going to wind up doing any math in this class. All right. So what I want to talk about today is basic circuits terminology. So effectively, before we bother ourselves with any circuit analysis, I want to make sure that we are literally speaking the same language, okay? So the first thing that I want to do is to introduce the concept of a general circuit element. So let's say that we have some circuit element A, okay? This is what's known as a two-terminal circuit element. So we have a terminal up here on the top and a terminal down here on the bottom. Terminals are used to make connections to other circuit elements. So for a resistor, the terminals are those metal legs coming out of the resistor body. For a battery, it depends on whether it's like a AA battery or a 9-volt battery, but it will have a terminal that's associated with the positive polarity and a terminal that's associated with the negative polarity. There are some circuit elements that have more than two terminals, like transistors. A BJT or a bipolar junction transistor usually has three terminals. A MOSFET transistor can have 3 or 4, depending on whether the bulk connection is needed or not. The overwhelming majority of the elements that we're going to deal with in this class are of the two-terminal variety. The only one that isn't is the op amp, which is actually an 8-terminal device, but we're only going to really concern ourselves with 3 of them, and that'll be a while down the road. Okay. So if I connect two circuit elements together, like so, I have formed a network. So oops. A network is defined as an interconnection of two or more circuit elements. This point of interconnection here is what's called a node. Right. Now, if we connect more circuit elements to our network, we wind up adding more nodes to our system. So let's say that I connect the generic circuit element C like so, and a generic circuit element D like so. I've now created more nodes in our system. When there are multiple nodes present, it's often a good idea to label and identify them, okay? How I like to do that is using different colors. So I'm going to identify this point of interconnection or this node between A and B in red, okay? Now, we are going to find that all points along the connected terminals are actually considered the same node, and we'll explain why that is actually on Monday. So for now, you're going to have to take me at my word. So what I'm going to do is I'm going to extend this red node all the way down to element A and all the way across to element B. So that all forms one single node. I'm going to do something similar for C. So we have a single node that connects elements B, C, and D. And finally, I'm going to identify my node that connects elements A, C, and D. Down here. Okay. So this circuit containing 4 elements has exactly 3 nodes. Okay. So what we're going to do now is look at how these elements are connected to each other. We're going to start by looking at elements A and B. Okay. So elements A and B share a single node between them. There's a single point of interconnection, and there are no branching paths off of that single point of interconnection. So we consider elements A and B to be connected in series. So a series connection is a connection between 2 circuit elements with no additional branching paths. All right. Now, we are going to modify this definition a little later as we get more familiar with applying circuital laws. But for now, we are going to consider a series connection as only possible between two elements, okay? If we look at elements C and D, we can see that they share the purple node, or pink, at their top terminal, and the blue node at their bottom terminals. So whenever we have shared sets of terminals, we have a parallel connection. So a parallel connection is a connection between two or more circuit elements where both sets of terminal pairs are shared. Okay. So to recap, elements A and B are connected in series because they have a single point of interconnection with no branching paths. Elements C and D are in parallel because they share a single node point for their top terminals and a single node point for their bottom terminals, right? So the top terminals are all connected to the pink node. The bottom terminals are all connected to the blue node. So let me ask you guys a trick question. How would we describe the connection between element B and C?
What do you combine C and D?
I'm not talking about any kind of combinations or anything like that. It can't be in series. So B and C can't be in series because there's a branching path that connects to D. B and C can't be in parallel because while they do share the pink node, they don't share the red node or the blue node, right? It's perfectly acceptable for elements to not be connected in series or not be connected in parallel, okay? This is something that I don't think is emphasized nearly enough in your Engineering 120 courses. It is not a binary decision of series or parallel. It's series, parallel, or none of the above. And none of the above is an absolutely viable answer to describe this electrical connection. Now, as this gentleman here suggested, we're going to learn how to do resistor or element combination techniques that can make things look like they're in series and make things look and behave like they're in parallel, but we're not quite there yet. So for now, series is a possibility, parallel is a possibility, neither is also a possibility, okay? So B and C are neither series or parallel, B and D are neither series or parallel, A and C are neither series or parallel, A and D are neither series or parallel, okay? It's okay that they don't fall into one of those clearly defined little buckets, all right? So I want you guys to consider this network here. Here we have an element A. Here we have some element B. Across this diagonal, we're going to have an element C. Here's an element D. Here's element E. Across this diagonal is element F. Down here is element G. And finally here on the right is element H. I want us as a class to look at this guy and answer the following 3 questions. Question A, how many nodes does this network contain? Question B, which of the elements are connected in series? And question C, which of the elements are connected in parallel? I think I put too many R's in parallel. All right. Let's start with question A. How many nodes do you think there are? You raising your hand saying 4 or 5? I couldn't, 5. Okay, 5. Raise your hand if you agree with the gentleman in the nice blazer. Pretty much everyone. Well, you're correct, okay? I'm gonna go out of my way to identify them, just so that we're all on the same page. So that's gonna be our first node. Here is our second node. This will be our third node. This guy in pink will be our fourth node. And finally, over here in blue, we will have a fifth node. So 1, 2, 3, 4, and 5. 5. Wonderful job. What's your name, sir? Justin? All right. Great job, Justin. All right. Somebody else tell me which of the elements are connected in series. Yes, sir.
A and B and E and H.
So A and B is in series. Absolutely. And E and H. Also correct. So we can see that node 1 doesn't have any branching paths. Node 3 connects exactly 2 elements and doesn't have any branching paths. So the elements that are connected to those two nodes must be in series with each other. Wonderful job. All right. Parallel. Which of the elements are connected in parallel? C and D. That's it. So C and D share the orange node, the top middle, and the pink node on the bottom left. Okay. Some people might be thinking that it's C and D and F, or C and D and G, but F and G can't be included in that parallel connection because they're connected to the blue node at the bottom right. Or, they have a connection to the blue node at the bottom right that isn't shared with elements C and D. Okay. All right. So I'm going to go back to my previous page and we're going to continue to define some things here. Okay. Okay, so whenever a network contains at least one closed path, we consider that to be a circuit, all right? So a circuit is any network containing at least one closed path. And just for the sake of argument here, I'm going to erase my colors that we used to define the nodes so that this drawing doesn't get too cluttered. Just real quick here. Okay. So our network here contains multiple closed paths, right? So it satisfies the criterion to be considered a circuit. So the next thing that I want to define is the concept of a loop, where a loop is just a closed path in the circuit. So a loop will be any closed combination of circuit elements and nodes. So how many loops does this circuit contain? Raise your hand if you think it's 2. Roughly 10 of you guys. Raise your hand if you think it's 3. More than 10. The people who said 3 are correct. Okay. So let's identify them. So if we go from A to B to C down to this bottom node and back up, that's one loop. We can go from C to D and back around. That's a second loop. And for the people who said 2, that's probably the 2 that they saw. But there is a third possibility of going around the perimeter. This guy is our third, right? Because a loop is defined as any closed combination of circuit elements, all right? So the last thing that we're going to define today is the mesh. And a mesh is any loop in a circuit which does not contain any smaller loops. So that means loop 1 would be considered a mesh, loop 2 would be considered a mesh, but loop 3 would not be considered a mesh because it contains loop 1 and 2. Okay, So that's the difference between a loop and a mesh. Being able to correctly identify loops and meshes is a big part of what's called mesh analysis, which we're going to cover in roughly 2 weeks' time. It's a very powerful circuit analysis tool. So if we revisit our example problem here, let's tack on another question. How many meshes does this circuit contain? Four. Each of the triangles is a mesh. So I'm going to call this guy 1, this guy 2, this guy down here 3, and this guy 4. Our last question will be how many loops does this circuit contain? And the easiest way to answer this one is to think about it as loops being combination of meshes, okay? So how many one mesh loops are there? Well, there's 4. How many two mesh loops? So we could form a loop by combining meshes 1 and 2. So that gives us 1. We could form a loop by combining meshes 2 and 3. So that gives us a second 2 mesh loop. And finally, we can make a loop by combining meshes 3 and 4. So that's 3 2 mesh loops. So just real quickly, I'm going to draw those and then I'm going to erase them because this is going to get, again, too busy. So this is one loop. This is another loop. And then this bottom triangle down here is also a loop. So there are 3 2 mesh loops. How many 3 mesh loops are there? 2. So we can combine 1, 2, and 3 into a single loop, and we can combine 2, 3, and 4 into a single loop. And then lastly, how many 4 mesh loops do we have? 1, just around the outside, combining meshes 1 through 4. So if we add all these guys together, 4 plus 3 plus 2 plus 1, I believe, is 10. All right. That is enough out of me for today. We are all ostensibly speaking the same language. So what we're going to cover on Friday will be basic electrical quantities, meaning that we are going to have give a well-defined definition for voltage, current, power, and energy, and talk about the relationships between those quantities. There will be an in-class assignment that's expected to be worked at the end of class on Friday. I'm going to post that today. You need to bring a printed out copy of that with you to class on Friday. I say a printed out copy. If you want to work it on your tablet or whatever, I don't particularly care either way since you're going to be submitting it digitally, but the expectation is that I'm not going to waste paper handing things out to you guys. So you're going to come to class with that in either a soft form, like on a tablet or something like that, or a physical form. Anyway. All right, have a great rest of your day. Hope you have a great spring quarter, all that kind of good stuff.